Okay, good evening, doctor. My name is Khalid Yunus, and today I'm going to be talking about one type of new SQL databases, which is the VoltDB. So I found it really useful website on database of databases. It's a website that describes many types of databases. I'm going to talk about VoltDB, obviously. So VoltDB is one of the types of the new SQL databases, which is scalable and ACID compliant. ACID compliant means it complies to the atomicity, uh, concurrency, isolation, and durability. So these types of databases are usually used in online transactions. These stuff which are ACID compliant, but there are other types of databases that are base compliant. This is the opposite of ACID. So Vault is one of the ACID compliant databases. It's also scalable, which is really useful. So you can expand on your available nodes in your clusters. It's a emulation database to work with the OLTP queries uh, that are usually uh, with online transactions. It is a shared nothing uh, in a distributed database, and with sharding is basically um, uh, to cut down your data into equal parts in half. So it's split on multiple nodes per cluster or on multiple beside each other clusters. It has two versions, 1GB, a commercial version which you can buy to get, and an open source community version, which I'm going to show later on GitHub link, which has all the source code. History. History of VoltDB. It originated from Store, a research project from Brown U and MIT under Michael Stonebreaker, Samuel Madden, Andy Pavlo. Those are the original creators of VoltDB. This was all in 2009. It started as a spin-off in Boston, Michigan. This is its early beginnings. This is not really important. Concurrency control. هلا VoltDB schedules transactions deterministically on each partition of the data in the cluster. So what does this mean? So when you have transactions on your cluster, the VoltDB partitions the transactions because it uses sharding, as earlier mentioned, and it schedules the transactions in order. So there's no loads on the master node, as you say. It's all scheduled. For transactions that span across partitions, a global serial order controller is responsible for determining the execution order. So if we have transactions that are available on several or multiple shards or partitions, we have a controller called the global serial order. It's responsible for determining the execution order. So the transactions may have some priority of some type, so they get the priority in execution or not. If you click this link, we have these are some type of databases that use this concurrency control feature, really useful. As you see, HStore here, the original VoltDB. These are other examples of the concurrency control databases. Data model. The VoltDB is based on the standard relational model, obviously, because it's a relational DBMS. So it is it's in the standard model. So obviously, there's a lot of databases that are based on the standard model, because the relational is the most used type of databases in the world. There are many examples. This website is really useful. If you want to know more about any database, so you can find it here. Link. Indexes. Apart from the default tree index, VoltDB also supports hash index. So what's that? As you all know, we have a tree index. What's a tree index? So you can have nodes. Each node has an index, and we can grow into leaves as in a tree diagram. But also it supports hash. Hash, as many of you have taken in its structures, the hash index. Isolation level. VoltDB supports serialization isolation level with asset guarantee. What does this mean? As I said before, VoltDB is asset compliant, so it supports good isolation while maintaining the asset properties, as mentioned before. The deterministic ordering of transactions is achieved by controllers at each data partition. So what does this mean? That remember when you said that the general node, general master, is the one who schedules the transactions when they come through. So those controllers, there is one at each data partition. So it schedules and prioritizes the transactions based on some criteria or not. Logging. VoltDB supports transaction level logging for all the stored procedures that are invoked. By command logging, the amount of memory overhead is minimized since a single stored procedure in invocation could contain an arbitrary number of SQL statements. So logging, as mentioned here, the amount of memory that is used by VoltDB is determined by command logging because and it can be minimized since one procedure stored could contain multiple SQL statements, or we could say, as we say, transactions. So this is really useful because it minimizes the memory use. Only logs after the latest snapshot are kept, and the logs are flushed to the disk at a regular interval. This is only in the enterprise edition. So what does this mean? So VoltDB contains snapshots. Snapshots are the logs of the transaction after they have been made. So when there's several transactions, the snapshot keeps updating and updating. Last shown snapshot is of the latest transaction, and it's the only one kept uh, as information about the log. And the logs are flushed to the disk at a regular interval. So after completing transactions, the logs of the snapshots are flushed to the disk to store for later. But this feature is only available in the commercial version, which is not free. You have to pay to get it. Logging. Query compilation, query execution. Obviously, it has those features, so you can perform your SQL transactions as you wish. Query interface. Apart from supporting most of the standard SQL statements, VoltDB also allows the user to define pre-compiled stored procedures. This is really useful. Why? Yeah, so VoltDB is not only for real-time now transactions. You can use pre-compiled procedures, and you can insert them on the VoltDB, and it will work as well. Storage architecture. VoltDB is designed to be an in-memory relational DBMS. Its data persistence is achieved by snapshots stored on disk. So VoltDB is stored in memory. That's the way of storage. It's relational DBMS, as we said. The data persistence is achieved by snapshots, as we said. Each transaction made will have a snapshot made of it, and logs of these snapshots are flushed to the disk regularly to keep consistency and persistence. Storage model. VoltDB is only designed for fast OLTP queries, so it requires online real-time transactions. That's why it's vital that it is an ACID compliant database. Stored procedure. The stored procedure in VoltDB allows the user to define a transaction once and to be invoked later with given parameters. So when you do a transaction or a procedure, you can only define it originally once. It can be changed, edited, or invoked later with the given parameters that you provided in your transaction. Stored procedures are precompiled to reduce execution time. So remember when you said that VoltDB accepts predefined procedures from before. These, when you insert them, they are precompiled. So maybe they're given less priority than active transactions. So this reduces the execution time. Temporary queries are automatically compiled and executed as a stored procedure. So sometimes we have not very important, only temporary queries that are to be done. These will be compiled and executed as a stored procedure, so they are pre-compiled and they are defined as a stored procedure. VoltDB supports stored procedures written in SQL or Java. When you want to pre-compile or insert a stored procedure, it only supports two types of coding, which are SQL and Java. System architecture. VoltDB runs on a sharded DBMS cluster. Data partitioning and application is not automatically across the cluster. So, as we said before, hardening or partitioning is the process of cutting down data into smaller partitions, spanning across nodes or clusters. This is to remove pressure from the master node in each cluster, and data can be accessed easily and much faster. This process is done automatically across the cluster. So any piece of information that or procedure that is really big on nodes in some cluster will be sharded or partitioned into smaller pieces and accessed later. Views. Views in VoltDB are materialized to improve read speed, and all updates to the original table will have a performance impact. So any procedure you do on your existing data will affect the data automatically real time. That's why VoltDB is really useful for OLT procedures or online real-time transactions. This is like a general idea about VoltDB and its features and characteristics. As you see here, this is source code on GitHub, which is here. These these are all the sources and codes, every information you need about the code of the VoltDB. As you can see, there's the source here, there are some tests. This is the VoltDB itself here, licenses, important notes, versions, history, everything you need is on this GitHub page over here. As you can see here, these are the components of the VoltDB. 12 years ago, as you said, it was made back in 2009. So yeah, this is everything you need right here in this GitHub page. And thank you for listening. This was about VoltDB, a type of a NewSQL database. This website is database of databases. It's also the website of its own VoltDB, the original website. It was renamed later in 2022 to Vault Active Data. Everything you need to know is here as well. So, this is the original data source of them, originally created of VoltDB. Features as well, I just talked about. real-time data scale without sacrificing performance, asset compliant, and yeah, thank you for listening and have a nice day.